Let us study the concentration of ores. Removal of the unwanted material, example, sand, clays, etc., from the ore is known as concentration, dressing, or benefaction. Concentration involves several steps, and selection of these steps depends upon the differences in physical properties of the compound of the metal present and that of the gangue. The type of the metal, the available facilities, and the environmental factors are also taken into consideration. Some of the important procedures are described: hydraulic washing, magnetic separation, froth flotation method, leaching. This is based on the differences in gravities of the ore and the gangue particles. It is therefore a type of gravity separation. In one such process, an upward stream of running water is used to wash the powdered ore. The lighter gangue particles are washed away and the heavier ores are left behind. We know that this process is used if there is a mass difference in the impurities as well as ore. Hence, a stream of water flow separates the lighter part from the heavier one, and the heavier one settles down in the grooves. Let us study magnetic separation. This is based on differences in magnetic properties of the ore components. If either the ore or the gangue, one of these two, is capable of being attracted by a magnetic field, then such separations are carried out. Example, in case of iron ores. The ground ore is carried on a conveyor belt which passes over a magnetic roller. From the animation, we can observe that the particles getting collected in the left box are non-magnetic as they are not attracted by the magnetic field, whereas the other one is magnetic in nature. It is not necessary that only ore should be magnetic, gangue particles can also be magnetic. Let us study froth flotation method. This method has been in use for removing gangue from sulfide ores. In this process, a suspension of the powdered ore is made with water. To it, collectors and froth stabilizers are added. Collectors Example: pine oils, fatty acids, xanthates, etc. enhance non-wettability of the mineral particles, and froth stabilizers, examples are cresols, aniline, stabilize the froth. The mineral particles become wet by oils, while the gangue particles by water. A rotating paddle agitates the mixture and draws air in it. As a result, froth is formed, which carries the mineral particles. The froth is light and is skimmed off. It is then dried for recovery of the ore particles. Sometimes it is possible to separate two sulfide ores by adjusting proportion of oil to water or by using depressants. In case of an ore containing ZNS and PBS, the depressant used is NaCN. It selectively prevents ZNS from coming to the froth but allow PBS to come with the froth. The given figure shows the arrangement of froth flotation process. Let us study leaching. Leaching is often used if the ore is soluble in some suitable solvent. The following examples illustrate the procedure. Leaching of alumina from bauxite. The principal ore of aluminium, bauxite, usually contains SiO2, iron oxides, and titanium oxide, TiO2, as impurities. Concentration is carried out by digesting the powdered ore with a concentrated solution of NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure. This way, Al2O3 is leached out as sodium aluminate and SiO2 too as sodium silicate, leaving the impurities behind. Al2O3 solid plus 2NaOH aqueous plus 3H2O aqueous gives 2NaAlOH4 aqueous. The aluminate in solution is neutralized by passing CO2 gas, and hydrated Al2O3 is precipitated. At this stage, the solution is seeded with freshly prepared samples of hydrated Al2O3, which induces the precipitation. 2NaAlOH4 aqueous plus CO2 gas gives Al2O3 dot XH2O solid plus 2NaHCO3 aqueous. The sodium silicate remains in the solution and hydrated alumina is filtered, dried and heated to give back pure Al2O3. Al2O3 dot XH2O solid at 1470 Kelvin gives Al2O3 solid plus XH2O gas. In the metallurgy of silver and that of gold, the respective metal is leached with a dilute solution of NaCN or KCN in the presence of air for O2, from which the metal is obtained later by replacement. 4M solid plus 8CN minus aqueous plus 2H2O aqueous plus O2 gas gives 4MCN twice minus aqueous plus 4H minus, where M equals to Ag or Au. 2MCN twice minus aqueous plus Zn solid gives ZnCN4 2 minus aqueous plus 2M solid.